Hi guys, we're going to look at calculating half-lives today and also learning how to handle your half-life, uh, any type of calculation you might be asked to do. So we need to look at a couple of methods for calculating half-life. The first method is the formula method, and then I will show you the chart method. So depending on if you're, some of you that are really mathy, you would like the formula method best probably, and then those of you that aren't quite as mathy, you would maybe like the chart method. But either way, I'm going to show you how to do it with both of the examples, both by doing the formula or the chart, and you can kind of just choose, as I said. Now, there will be times that the chart method will be probably faster, but there's also times that the formula method would be necessary because of the complexity of the type of problem. So let's just look at both methods. Remember, class, that half-life is the amount of time it takes for 1/2 of the original sample to radioactively decay. And so after every half-life cycle, 1/2 of the previous amount will remain. Now, the formula method involves the formula 1 over 2, there you see your 1/2, to the nth power, times x sub 0, that means x initial, your initial amount, equals x sub f, which is your final amount. So let's define each of these variables. N represents the number of half-life cycles. Now let me show you a little formula here that would relate your half-life cycles to the half-life itself. But sometimes we are told the total time that has passed, and we're told the half-life, and we have to figure out the number of cycles. So the way that you can figure out the number of cycles, and so again, N is your symbol for cycles, it's going to be calculated by taking your total time that has passed, dividing that by your half-life period. So T1/2, remember, is your half-life. Now, x sub 0 represents the original amount of the sample. And x sub f, the f stands for final. It represents your final amount of the sample. All right, so that's the formula method. And again, the formula is here. And this will be a handy formula to remember as well. We'll be using both of these. All right, for the chart method is a little more, you just think it through, but it involves a chart, I call it a T-chart. And your headings here will be, for the first one, the amount. So it's like the amount of your sample. And the other heading is time, or you could define it as cycles. I usually do the cycles, okay? So you'll see when I do the example what I mean by that. All right, so for the amount, you're always going to start off by your original amount. The original amount will always go here first in your first row. And then what's very important using this method is you remember in the very beginning, no time has passed by. So you're always going to say 0 in the first for under the time or the cycles. So this right here must always be 0. And then you just you have to think this through. So this can get kind of long if you've had a lot of cycles go by. So you just kind of make your chart and you cut it in half, cut it in half, cut it in half, cut it in half, divide by 2 each time. All right, so let's look at the first example in your notes. This says the half-life of iodine-131 is 8 days. So this, they're telling you, is the T1/2. That's what that is. It says what mass of iodine-131 remains. So that means that's how much is left in the end. So that's going to be your x sub f that you're looking for. After 48 days. So this is the total time that has passed. Then it says if the original was 4 grams, so the original amount, this is your x sub 0. So just trying to identify our variables here. So let's use the formula method first. So remember, the formula is 1 over 2 to the nth power times x initial equals x final. So we need to figure out how many cycles have gone. So I'm going to use the other formula here where your cycles is equal to total time. I put TT for total time divided by your half-life. So the total time that has passed is 48 days. And they told you the half-life was 8 days. So 48 divided by 8. And so that means that 6 cycles have passed. So n is 6. So that's going to plug in here. So 1 over 2 to the 6th power times x initial. The initial amount is 4 grams. So times 4 equals x final. So mathematically, you're going to plug in basically 4 divided by 2 raised to the 6th power. And so when you do that, that gives you 0.0625 grams equals your final amount. So that's your answer. All right. And with these, you don't really have to worry so much about significant figures because you are going to get some very small amounts here if many cycles have passed. So we'll just say 0.0625 grams. Now, let me show you how to do that using the chart method. So, chart method. Okay. Now, with the chart method, you're going to start off, remember, at the top is your amount in your first column. And then I'm going to do cycles. Remember, your first cycle is always 0, and in this problem, the initial amount was 4 grams. Now, in this case, we figured out that 6 cycles had passed. So what you have to do is you have to divide by 2 6 times. And this can get a little lengthy. 1, 2, 3, 4. And I'm going to move over here. I didn't leave myself a lot of room. So finish my chart here. 5, 6. Okay, so this is the point that we will stop dividing by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 0.5. 0.5 divided by 2 is 0.25. 0.25 divided by 2 is 0.125. And then here we get to the end, which is our answer. 0.125 divided by 2 is 0.0625. And remember, it's grams. So that will be your final answer on that one. All right. Either way, you get the same answer. All right, let's look at example 2. This will be our last example. So this one's a little different because it doesn't actually give us an original amount. It says the half-life of thorium-234 is 18.72 days. So the half-life is what they're giving us. Here, it says how many days are needed. So this is the total time. They're wanting us to figure out the total time that has passed. Now here's where you got to really read it. It says for 3/4 of a given sample to decay. They don't tell us how much we started with, but it's 3/4 of the given sample is going to decay. So let's just think in terms of a pie chart. Okay. So if you think in terms of a whole, and we're going to here have to define our x initial, we're going to call it the whole or 100%. And so 3/4 has decayed. How much remains at the end? Well, 3/4 are gone. That means 1/4 of it remains. So that means at the end, x sub f is 1/4. So x final is 1/4. All right. So this one here is going to be easier to use the chart method. So we'll do amount, and then we'll do cycles. So remember, the first cycle is always 0, and our original amount, we defined it as 1. So you're going to cut it in half till you get 1/4. So divide by 2 is 1/2. Divide by 2 is 1/4. And this is where we stop. So 2 cycles. So you're going to say 2 cycles times your half-life, which is 18.72 days.